This is a tutorial on setting up a slab-on-grade condition on the PHIUS branch Foundation Interface tab in WUFI Passive. In a blank WUFI Passive project, under the PHIUS branch, you have the option of setting up the Foundation Interface tab. What this is doing is determining how is the building connected to the ground and what will the resulting ground temperature below the building be because of it. There are different options for the setting, which I recommend is always choosing user defined, and then the type. This particular tutorial is for the slab-on-grade condition. At the top of the foundation interface screen, you see there's an option here to add multiple foundation interfaces. You can add up to 3 different foundation interfaces. You may have a project where part of the building is slab-on-grade, part of it is crawl space, part of it is heated basement, etc. So up to 3 different conditions can be defined, and the different parameters for each of the different interfaces should be defined. For here, we will select 1, and we will select slab-on-grade. So you can name the foundation interface if you'd like. I'll name it slab-on-grade. Setting here is user-defined, type slab-on-grade. And then next, for the parameters, depending on your geometry, you should always be able to check from visualize geometry for the floor area. If not, you can select user defined and enter the floor slab area. The U value on of the slab on grade can also oftentimes be detected automatically. When you're first filling out your project and you select from visualize geometry or detect automatically, you'll see there's no values over to the right hand side. That is because there's not final results in your project. I do not have results. I haven't created my slab assembly yet. It doesn't know what the floor slab area is. However, typically you can select from visualize geometry and it should work appropriately once you get your results, and I will show you that. So I will do that for the floor slab perimeter as well, the bottom entry. But again, you can manually enter the floor slab perimeter. You can also use this ... box over to the side and do some sort of calculation. So let's say I have 5 and 20 plus 5 and 20, something like that. Okay, so user defined, but I will pick from visualize geometry. So again, these top parameters usually can be detected automatically based on the geometry. For slab-on-grade conditions, that works every time. The additional parameters below are for the perimeter insulation. So for any given project, if there's slab insulation below the slab, if there's perimeter insulation that extends apart from that, for example, this is the sample project, Carpiac Moha Residence in Pennsylvania. If there's slab insulation that extends below the slab or out of the slab, the typical slab insulation, such as this wing on the side, this can be entered as perimeter insulation. So here we may have a frost skirt or frost wing that's about 24 inches wide and maybe 2 inches thick. Based on this being about 12 inches, this appears to be about 2 inches. So this particular case in WUFI Passive would be set up as horizontal perimeter insulation. You have the option of saying there's none, vertical or horizontal. I'll pick horizontal. The width is 24 inches. 2 feet. So you see perimeter insulation width or depth is in feet, so 2 feet. And the thickness of perimeter insulation here was also 2 inches, so I'll put inches, so be careful with the units here. And then the conductivity of the perimeter insulation, we will say in this case was EPS, so we'll pick R4 per inch. Be careful in WUFI Passive, there's options of entering conductivity and R per inch. If you'd like to enter R per inch, always click on the box that appears and enter the R per inch there. So I've entered R4 per inch here, and the conductivity is 0.021. So you have very different results if you accidentally entered the 4 here. So make sure the 4 is always entered here in the R per inch pop-up box. You also have the option of entering the phase shift months and harmonic fraction, but please do not use the default, or please use the default values unless you can provide justification for certification on why you're revising these particular values. In a filled out project, the foundation interface may look like this. So visualized geometry was selected, and it's detecting the floor slab area automatically. We can check that by looking at our geometry at our floor slab here. Area of our floor slab here is 1151. Back in our foundation interface, 1151. The U value of the slab on grade comes from the different component we created for this assembly. So that's also found by clicking on our slab. The U value is the very bottom entry here, 0.0186. And on the foundation interface, it's just rounded it to 0.02, but it is using the actual value from the component you created for the slab. The floor slab perimeter, again, is taken from visualized geometry, but we could check it here by clicking on the floor slab, looking at the perimeter here, 136.67 feet under pH case. That is also what we have here. So again, these values are calculated, and then from that it determines at the very bottom what it thinks the ground temperature below the building may be in the different heating season and cooling season for each month. So depending on the level of insulation between the building and the ground may be warmer if there's less insulation, or colder if there's more insulation in the winter.